So we will be moving to fluid statics. Suppose we are considering a cubical portion of some fluid. Okay, a cubical part is considered. Now this fluid is in no motion. That is why fluid statics. Now if we are considering stresses in all the planes, okay, cube, since we have considered a cube, we have 6 planes, and along those planes we have along the plane stresses and normal to the planes. Now along we are considering some coordinate system like this x, y, z, and if I am considering this plane, we have normal to that sigma x6, and along y direction we have tau yx, and in this direction, that is tau zx. So similarly in all the planes we have, that is first letter indicates along the direction of the stress and second letter indicates that plane. Plane means we will be saying this plane x-axis is normal to it, so x, that plane is denoted as x in that way. Okay, now if that is the case, now along the plane means these two tau zx, tau yx are shear stresses. Now what is shear stress? Resistance to fluid which is in motion. So in fluid statics, this shear stress is not coming into picture. Only normal stress, sigma normal stress is coming. Now coming into view, now this normal stress we are calling it as pressure due to fluid. Okay, fluid means it can be liquid, gas, water. Fluid can be liquid, gas, water. Okay, that normal stress exerted is pressure only. So any fluid exerts pressure, and this pressure is exerted on whatever container it is. Suppose we have a container with some fluid, the walls of the container experiences pressure like this. See, all the walls which is in contact with the fluid experiences pressure due to the fluid. Now pressure is nothing but force per unit area, which has its SI units as Newton per meter square. Okay, now the same cubical portion we are considering, which is in statics. Suppose a cubical container we have with some fluid in it. Okay, now the bottom side of the container also experiences some pressure. Okay, say it this way. Now this, if that is the case, what is the force pressure into area only? See, if that P into A, that is the case. Now so the bottom side of the container experiences a force pressure times area, but the fluid is in this direction. Suppose this is the Z direction. Okay, the net force anyway should be 0. That because fluid is not in motion. And what other forces you can see there? Due to gravity, weight due to gravity. That can be expressed as, which can be expressed as density of the fluid, density of the fluid, density of the fluid times volume of the fluid, which is that area times the height. Okay, the volume of the fluid, density times volume of the fluid. Volume is area times the height, so we will be getting the mass of the fluid times G is the downward force due to gravity. So they should be balancing each other, so that force along is a direction, or the vertical direction is net force acting in that direction will be 0. That means this P can be obtained as rho g h. This indicates something more. This pressure depends only on the height of the fluid, and there comes the Pascal's law. Then if we have different shape of containers like this, containers in different shapes, this is so common, which this is so general thing which everyone might be knowing. We have containers of different shapes, and if we are pouring fluid, everyone will be attaining the same height because of the same principle. All will be attaining the same height. So because pressure at the same levels will be the same. Only pressure we have on the surface is atmospheric pressure. That should be same everywhere. Here we have atmospheric, here we have atmospheric pressure, here we have atmospheric. And at the bottom, same liquid only. Density is same throughout. So weight is rho gh. Rho gh, pressure is rho gh. So that is one general thing everyone must be know. And that is Pascal's law, that is intensity of pressure at any point in a fluid at rest is same in all directions. Now so the same is known as Pascal's law, and its major application is in hydraulic presses, or in workshops we have cars lifted using this principle only. There we have that. See, we have a container with some fluid here. So this is the container with some fluid, and we have a piston. This one is the piston. Using this, we will be applying a small plugs. Another application of the same include manometers, that is for measurement of pressure, measurement of fluid pressure. We can use the same, and they are called manometers. And manometer can be of different types. They can be uh, a U-tube manometer. Suppose this is a U-tube and it contains some fluid. Usually mercury is used. Why mercury is used? Because its density, if you look into the density of mercury, it is relatively high as compared to water. So the measurement scale can be, suppose instead of mercury we are taking water. For getting the same amount of weight, we have to use the specific gravity of mercury is 13.6, that is with relation to fluid. That means for getting the same weight of mercury we have to take 13.6 times larger this device. So in order to minimize the size of the device only we are taking mercury. So it contains mercury. Now suppose we are introducing some fluid here. Okay, another fluid. So what we are taking? We have to take a level. Suppose this level we are taking, pressure at both ends at the same level should be same. So will be in that way only we are doing the calculation. So what we are doing, pressure due to the fluid Pg plus whatever mercury, sometimes mercury on introducing the other fluid, mercury level might have gone this much height up. See, this total is mercury, so we can neglect that. So Pg is only this much. Okay, I mean at this level, up to this level we have this pressure of the fluid, new fluid introduced. So what we can tell, Pg is equal to whatever height mercury have moved up. Rho g, this rho is mercury only. H mercury height at the other limb, whatever height mercury has risen. So this is the way we calculate. This is the basic principle of working of manometer. This itself can be modified in different ways. The only thing, at that same height we have the different we have same pressure. Now for measuring blood and all, in olden times though we used the same principle, today we have digital manometers where the pressure introduced by the blood on the spring of transducer will generate a signal and it is measured. Okay, that is how. So this is the basic principle of manometers used for measuring fluid pressures.